Hello, Woodstock Science students. Welcome to this little talk on concentration and how one can calculate the concentration of a solution and how one can actually use that information or that idea to gather up the right amount of material to create a very specific concentration. If you've been in the biology class, you're familiar with this slide where we've developed the idea of a dilute or a concentrated solution that depends upon a little bit of material or a lot of material. And we're going to build from this in just a moment. Let's start by looking at how one can actually just calculate the concentration of a solution. Here we'll kind of focus on the image on the right hand side, assuming that there's 20 grams of salt. That's then going to be dissolved into solution in 100 milliliters of water. One thing to recognize about water is that if you have 100 milliliters of water, you have 100 grams of water because the density of water is 1 gram per milliliter. So we're going to focus on just solutions today that involve water, and that's probably going to help us quite a bit. But please note that in essence, even though we've got grams of salt and milliliters of water, we have grams, and if we were to compare those two, if we were to divide, say, one by the other, the units would cancel and we would just have a percentage. And in fact, that's the way we're going to define our concentration. There are several concentration definitions, but the concentration definition we're going to use will be called the percent concentration. So let's begin. To calculate the concentration as a percentage, we'll start here with this percentage concentration, and it's simply a ratio. It's the mass of the solute. We haven't used that word before, but solute is the amount of material that's going to be dissolved in a solvent. In this case, the solute is the salt, and the solvent is the water. We're going to take the mass of the solute, the salt, and divide it by the total mass. That's the mass of the salt and the water in this case. And here's an example. If we had, or the example shown just above, if we had 20 grams of salt dissolved into 100 milliliters of water, that's 20 grams of solute divided by a total of 120 grams of total material. That turns out to be 0.167, or by sliding the decimal 2 places over, 16.7% salt solution. Well, what if you wanted to create a specific percentage concentration, a 5% sugar solution or a 15% salt solution? How would you proceed? So the question then really becomes, how much salt should I put in? And to make things a little bit simple for the moment, we're going to assume that we're going to make 100 milliliters. We'll use 100 milliliters of water. That's going to give us a total volume, total mass of somewhat more than 100 grams of water. But that's probably a simple thing for us to start with. You could start with a different amount of water if you wanted to, but here's just one simple way to proceed. We've got our definition. The percent concentration is the mass of the solute, which is what we're trying to find, divided by the total mass. Now, I've gone ahead and I've done a little bit of algebra here, and we get to the end here, and let's see if I have this. There we go. Get to the end. And I have a formula here for the amount of the solute that we're looking for. You're welcome to look through all these steps here, but at the end we're going to have 100 times C, and that's going to be divided by 1 minus C, and that's going to give us the amount of solute that we need. The 100 comes about because we assumed 100 milliliters of water, so if you wanted to make a full liter of this solution, you'd put 1,000 milliliters in there. So that 100 is just the mass of the water. So if we start with 100 milliliters, we would put this formula into play to figure out how many grams of salt you should put in to make a specific concentration of the salt. Where C is the concentration of the salt, but expressed as a decimal. So in our previous example, if we started with 16.7%, the value we'd put in for C would be 0.167. So here's a specific example. What if we want to create a 12% concentration of salt? How much salt should I put in? Well, let's go There's all the algebra again, but let's go right to the end and let's put in the values as they've been expressed here. Again, 100 milliliters of water, so it's going to be 100 times my concentration, 100 times C. So in this case, it's going to be 100 times 0.12. That's 12% concentration. That's going to be divided by 1 minus 0.12. That becomes 12. 100 times 0.12 is 12, and the denominator is 0.88. If I divide 12 by 0.88, I'll come out with 13.6 grams of salt. So you carefully measure out 100 milliliters of water, carefully measure out 13.6 grams of salt, mix them together well and make sure the salt is dissolved in the water, and you would wind up with your 12% concentration. You'd have 113.6 grams of a 12% salt concentration. There are lots of variations on this, and you can play around with this, but this gives you a pretty good sense of how to create a very specific percent concentration. I hope that's helpful.